sharing sacred geometry with us.
All right. Well, with an intro like that, I don't really know where I can go from there, so thank you. I appreciate it. Thanks for having me. Today we're going to do a lot of drawing. So who remembers math class? Who remembers what it felt like? Did you ever get in trouble for getting distracted? Yeah, I got in a lot of trouble in math class because I used to argue with the teacher about philosophical points. She would tell me, oh, this is a point and it's infinitely small. And I would go, well, if it's infinitely small, how can you define it as existing? And then she'd be like, no, that's not the point. I'm like, see, you said point. I was really, I feel sorry for my teachers. I was kind of a pain. But what I've got here for you today is an interactive workshop that's going to be a lot of fun. We're going to draw a whole bunch of shapes. We're going to explore the numbers 1 through 5. We're going to explore harmony and proportion. But the first thing I want you to do is look at your table, and each table has one of the 5. Does anyone know what they're called?
Platonic solids.
Platonic solids. So does everyone know what these represent? Like, for example, we've got the tetrahedron over here. Does anyone at that table know what that represents? Can you answer, do you know the basic correspondence of the tetrahedron? It's okay if you don't know the answer. Triangles.
Each side is equal to every other side in
Yep.
proportion.
Every side is equal to every other side. Alex, you had something?
Each one represents an element, the last one being like ether.
There you go. So what element is the tetrahedron?
Fire.
Fire. And if you look at it, it looks kind of like, that makes sense. I mean, I've built a campfire before, and it kind of, you get the little A-frame thing, and you light the kindling, and the flame goes up. If you look at the octahedron, octo being 8, that has 8 sides to it. Does anyone know what element that traditionally represents? Air. What about the icosahedron? Aside from being Dungeons and Dragons dice, water.
Is that the dodecahedron?
No. Coming up. So then over there we've got the cube, also known as the hexahedron, hex being 6. Does anyone know what element that represents?
Earth.
Earth. And then finally the dodecahedron, ether, or spirit. So we have 5 elements. This is a very, very old set of correspondences. But every one of these shapes actually fits inside of each other. They all fit together in a really interesting matrix. That's a 3-dimensional matrix that just so happens to correspond to the physical structure of the DNA, the pattern of DNA. That's kind of interesting because we've been pondering this and studying this for thousands of years. They're named after Plato, but they're much older than him. They're the divisions of 3-dimensional space that appear in the human body and all the way up into the solar system. There are ratios and harmonies and proportions in these things that appear everywhere. So I wanted to start off with just feeling and holding these in your hand and thinking about the way space is shaped and evenly. There's only 5 shapes that follow these rules. And I'm going to do a short intro lecture, and then we're going to start drawing. And you're going to draw things 2-dimensionally, flat on a piece of paper. But at a certain point, if we're really efficient today, hopefully we'll get to the point where your 2-dimensional drawings will jump out of the page 3-dimensionally. And you will be able to draw in perspective the 5 platonic solids. Sound like fun? All right. Any questions before I do my intro lecture?
I'm pretty sure I can't spell any of those things. Dodecahedron.
Yes. It's okay. You're not going to get a bad grade for not being able to spell dodecahedron. And one note, one kind of point of order, before we get started, I want to encourage all of you to doodle, and I want you to be encouraged to let your minds wander. I will not be offended if you're just messing around drawing pictures and kind of half listening, because I know that the part of you that's the most powerful is fully listening. Right now, I know you're fully listening. But there's part of you that might want to just kind of wander around. And that's something you would have gotten in trouble for, I'm guessing, in school. You're not going to get in trouble for that here. In fact, you might just draw something really beautiful. That's why you're here. So without further ado, I'm just going to go into this lecture, and then we're going to draw some shapes. For the most highly educated people in the ancient world, the study of numbers and geometry had a sacred element to it. It had a philosophical side that's been discarded in modern math classes. We tend to keep things very tactical. It's either useful for some counting or measuring purpose, or it's considered a different subject entirely, philosophy or theology or something speculative that's not going to land a probe on Mars. Speculative or philosophical math is simply not taught in schools for the most part. It's still there, though. You can go beyond the mere calculation of objects, and you can learn to see geometry as the language that the book of nature is written in. It's a tool that can be, in the words of Michael Snyder, author of The Beginner's Guide to Constructing the Universe, applied functionally to facilitate the growth and transformation of consciousness. You got it. This is a great book. Highly recommend show it to the camera. I highly recommend getting a copy of this book. It's a beautiful book. Michael Snyder lays it out, the numbers 1 through 10. Much of what we're going to be talking about today is from this book and from a couple of other books, including Sacred Geometry. If you want to get really technical, this one goes down the rabbit hole on geometric proofs. If you're a thinker, if you want the proof, if you want to see that this is actually not just a bunch of BS, but it's actually really well proven, this book has a lot of proof in it. And I'll get to what it is that we're proving in a minute. Because again, we're not landing rocket ships on the moon with this kind of math. If you tried to land a rocket ship on the moon with sacred geometry, you would crash. So that's not what it's for. So let's be clear about that. So not to just think about it, but to actually meditate it and really do it. How do we do this? How do we use sacred geometry to facilitate the raising of consciousness? We'll take the first steps today. Before you do anything else, write down the titles of these two books. So Sacred Geometry by Robert Lawler and Beginner's Guide to Constructing the Universe by Michael Snyder. These two books will keep you busy for many years, and their bibliographies will keep you busy for decades. In Snyder's book, the numbers 1 through 10 are explored as cross-cultural archetypes. Each one has their own powers, their own attributes. Using the geometer's tools, the compass and straight edge or square, those numbers can be created on paper by drawing circles and lines, following the rules of construction, based on how early land surveying was done with sticks and string in the ground. So when you have a line and you're drawing holding a stick, and the other person is walking in a circle with that piece of string in their hand. That's how the floor plans of buildings used to be developed, and still are in some ways. We have better tools, though. We have lasers now. So geometry literally means earth measure. Geo is earth, metry is measure. The starting point for building a temple. When you draw these shapes on paper, you are symbolically reflecting the archetypes and the symbols of the greatest sacred architecture of all time. You're playing the role of the architect. The paper represents the earth. This is an act of reflection. So take it like a form of meditation and allow yourself to doodle and be creative. If we are all made in the image of God, the Creator, that means that we are all creators ourselves. So as I talk, as I said before, I will not be offended if you're looking down, scribbling and doodling and playing around and staring out well, there's no windows, but staring off into space. This is not a normal math class. There are 3 types of math. Secular, symbolic, and sacred. And in a normal math class, what I would think of as muggle math only covers the secular. So secular math is what's taught in school. It's incredibly useful. Anyone who actually likes math, I'm not actually bashing math. Math is cool, but it's only 1/3 of what's out there. It's purely physical, materialistic, and very intellectual. Like I said, great for landing a rocket ship on the moon. Absolutely required for industrialization, for the modern world, assembly lines, computers. Everything that is functional and correct in the modern world depends on this. In the atheistic worldview, which secular math tends to encourage if it's separated from the other kinds of math, there's no architect. So there's just a bunch of raw materials that somehow accidentally self-assembled over millions of years. If you believe that this is all an accident, I think you might actually have more faith than the most devout Christian on the planet, but we can save that for a different discussion. The second type of math is symbolic math. With symbolic math, everything becomes a symbolic language. Number is quantity, but each number is associated with an archetype. The archetypes are expressed through cultural symbolism, often seen as gods or goddesses, or spirits, or spiritual principles, symbols, allegories, stories. This is where we start to see patterns emerge that have real beauty, and there's amazing coincidences. So the math behind music theory appearing in DNA, and the geometry of the 5 platonic solids appearing in the solar system, and the movements of the planets with 99.97% accuracy. Again, that 0.03% accuracy is enough to crash your probe, but that 99.97% accuracy is enough to reveal harmony and beauty. If you tried to, I already said that, so if you tried to land a probe. So the third one is sacred math. Sacred means set aside, consecrated, holy, set off, set apart. Anything sacred is something special or different, marked for a particular type of use. In this case, it's using the meditation on mathematical symbolism to transform and elevate consciousness. To elevate math to this level, you have to be using it in a functional way to improve yourself somehow. Does that sound familiar? The idea of using symbols to improve oneself? It's kind of an interesting concept to be discussing in a Masonic lodge. In sacred math, there is an architect. The act of studying actually is a spiritual quest. Symbols are used functionally to create sacred space. Symbols are integrated into everyday life, and they're felt in your heart as a connection to the divine. Symbols are like mandalas or meditation aids. They help to focus and elevate consciousness. Let's skip to 3 worlds. Let's see. So there's 3 worlds that we're operating in here. The typal world, the world of types, is the world of the world of things. Sorry, not forms, things. Objects, physical stuff. Secular math is only concerned with the typal world. It's about organizing stuff. It's like being an accountant. It's a spreadsheet. Again, very useful. An example of a type would be like a bridle on a horse. If we get into the ectypal world, ectypal is the world of reflection. That's the world of symbolic math. So that's symbolism, that's branding, that's the world of ideas of things. The ectypal is a copy of the typal. And the original is the archetypal, the pure form of the first principle, which all symbols are attempting to imitate. An example of this would be the category of bridles for horses. So again, the bridle is the thing. The category of bridles, you could have a bunch of different kinds of bridles. You could have different shapes, different colors. You could have a logo that was kind of like the symbol of your bridal shop. Not bridal, but bridle for like horses, right? That sounded kind of funny. And so that's where branding operates in the ectypal world. But in the archetypal world, to quote Robert Lawler, author of Sacred Geometry, universal processes or dynamic patterns can be considered independently of any structure or material form. This is the ultimate parent category, symbolized through common stories, dreams, gods and goddesses, and symbols across cultures. This is where you go from bridles to the idea of bridles to the universal principle of leverage itself. And that principle is the only thing that's actually real. One day, all bridles will turn to dust. One day, the category of bridles will no longer exist. One day, the last horse will die. Leverage will still exist. So the archetypal world is the highest level of symbolism, and that's what we're actually copying with our symbols. The only thing that's real is the archetypal. It's the part that you normally can't even see. All right, so let's get into some rules of construction here, because we're going to actually draw some stuff. I know I said we were going to draw, and then I just talked a whole bunch, but we are going to draw some stuff, I promise. So with the 3 types of math, the higher levels include and transcend the lower levels. There's no rejection of secular math. We use it to prove the constructions. If you read the books on the table over here, they're filled with proofs. So all of this is disprovable, and you should absolutely challenge it. But understand the frame that you're operating in. So if you're trying to prove or disprove a construction, you're not necessarily proving or disproving an archetypal principle, or whether or not a symbol is interesting. So there's different categories happening here. So here's the rules of construction. And you might want to write this down, or at least have some kind of a shorthand for this, because in a minute when we start drawing, I want you to remember this. It's really important. If you get a compass and a straight edge, and you start just drawing random stuff, and it's one thing is not connected to the next thing is not connected to the next thing, then you can quickly kind of veer off into just disconnected scribbling, which doesn't actually connect the idea to the next idea. I know that may sound kind of thick, but here's the first rule. You can only use points, arcs, and lines that you already have to make new points, arcs, and lines. So in sacred geometry, there's points, there's arcs or circles, and there's lines. You can only use the ones you already have. So you'll see in a minute when we do our first construction, you can't just have something floating off in space and connect it back, because it's not mathematically connected to what you just did. It'll break your proof, in fact. The second one is everything starts with a single point within a circle. So you have a point within a circle, that's the beginning of every construction. From there, you can choose any point on the edge of the circle. Keeping the compass the same size, you can draw a second circle. This gives you 2 new points. That is the very beginning, that is the opening to the whole thing. It's called the vescopisis. The next rule of construction is any 2 points can be connected by a line. So when you have a crossing of a line and an arc, it creates a point. Any 2 points that you've made can be connected by a line that you create. You look like you have a question.
I just asked these guys to answer for a point in a circle, not in a circle.
The point within a circle, in the center of a circle. And I'll review these again before we go in. So anytime a line or in a circle or arc cross, anytime things cross, a new point is created. You can use that point. And you can use that point to make a new circle or to connect it to another point to make new lines. So you're just, go ahead.
Does that have to be a midpoint?
It has to be defined as a crossing. Yeah, and you'll see in a minute. I mean, I'm going to review this a couple times. So I know some of you are kind of looking at me like, what? So you'll see it. We're about to get into it. It's fun. You'll get there. And then you can make any circle or any line from 2 points. So you just need 2 points, right? And then points can make more points, and it just goes on and on and on and on. Once you do a couple of these, you'll start sort of doodling and scribbling, and it'll make more sense. So the tools, you got the rules. Now the tools are the compass and the straight edge and the pencil and nothing else. You don't actually need a square. Now the square is a symbol that we're used to seeing. It's a 90-degree angle. It gives you a 90-degree angle. You have to kind of earn your own 90-degree angles in sacred geometry. You can't just have a 90-degree angle. You have to construct it from prior points, lines, and circles. There's a couple of principles here that I'm going to say for tools. When you use these tools for a sacred study, remember that they're ancient, very ancient. This is really, really old. They express divine proportion, using them as a form of meditation. The measurements come from the construction, not the tool. I'm going to say that one again, because this is a completely different way of thinking about it. We're not using a ruler to mark off lines in the sand, right? We're not using a tape measure that has marks on it. The measurements come from the construction that you make, not from the tool. So there is no tool that you're going to use to measure this. You are the tool, in a sense. Everything is a reflection type. Every shape that you make can be tied back to something. Nothing is perfect if it's physical. So when you draw something, it will not be perfect. Glenn and I were talking about that earlier. he was drawing some stuff and it was like, no matter how perfect you try to make it, your physical expression of it will not be perfect, but you're expressing something that in its ideal form is perfect. And it's not a good idea to erase your mistakes. Just draw it again. So the compass has one role: to make a circle from a central point. The straight edge needs no measuring marks. You hold it firmly, and every line is a path of energy. And then a pencil stroke is firm, steady, without hesitation. So try not to waver. Just draw it and commit. Commit to it. So we start with the void. This is the number 0. It's before number. The infinite void becomes aware of itself and expands to create a space which is not itself. And it then contracts to fill that space with itself, becoming everything and nothing. So that's the very beginning. Now, if you take your point and put it on the paper, the monad is the number 1. Go ahead and take your point and put it on the paper and draw a circle. So I'm just going to go from table to table and make sure no one has any issues drawing a circle. And you want to kind of tilt just a little bit. So you'll see, like, I'll just demonstrate here. You put the point in the middle, and then when you draw it, you got to practice it a little bit. If you push really hard, it could slide around. You want to keep the pressure on the center, not on the edge. Does that make sense? Is anyone having any problems with it? So when you draw that, check this out. You can kind of tilt forward a little bit so that you're almost dragging it behind. Yeah, there you go. That's it. You're kind of, just want to make sure everyone's got the right idea. Yeah, good. There you go. Yeah. Okay. So congratulations, you drew the number 1. So go ahead and just practice drawing circles while I talk about the monad for a minute. The circle has one center and it has an infinite number of outer points. So it's the one and the many. And I'm going to talk about the archetypes and the principles a little bit as you draw circles. Circles represent a pregnant womb. 1 is the universe's only common denominator. It's the only common denominator in the universe. The word universe, does anyone know what that word breaks down into? Alex? One turn, one verse or turn. So there's some great artworks of God, the geometer, turning a compass, creating the universe. Like old, beautiful paintings. This concept's been around for a long time. So you're reflecting that right now by drawing. That's why I have the God, the geometer picture right there. There's 3 principles to a circle. The 3 principles are equal expansion. So it's equal in all directions. Then also the idea of cycles, circular cycles or periodicity. That plays itself out in all kinds of ways in life. Moon cycles, day, night, all kinds of cycles. And the division of efficient space. Circles are everywhere. Now we're going to move on to the dyad. So the circle is a womb, but I didn't say that it gave birth yet. I said it's a pregnant womb. So if you imagine the circle as this pregnant form, it has not yet given birth. It needs to open. And that's what the dyad does. So what you're going to do is make a circle now on a fresh page. So turn the page. And we're going to follow the rules of construction. If anyone has a question, just go ahead and raise your hand. You look.
Does the dyad have a numerical representation?
2. So we're going through the numbers 1 through 5. Yes?
Is the void 0 or the void?
What's that?
Is the void 0 or the void?
The void is 0. Yeah. monad is 1, dyad is 2. So you're going to draw a circle, and just raise your hand if you don't have it. If everyone's got it. Now what we're going to do is take the point of the compass and put it on the edge. See, there's a dot there? Put it on the edge of the circle and draw another circle without changing the width of the compass. I'm going to give you a minute to do that. Some of you guys and girls have already done this a lot, and others are probably doing this for the first time. So if anyone by them, help them out. And I can also kind of go around and help. But if you're all good, then just practice drawing the vesica piscis. Does anyone know what vesica? Yeah. Oh, see this book right here? This book has like thousands of corporate logos, the greatest logos of all time. And so much of it is sacred geometry, it's ridiculous. I mean, you could probably find a bunch of vesicas in here. So if anyone wants to look through it. So the vesica piscis, it means belly of the fish. So that in the middle there looks like a little fish. And it's the belly of the fish. That is a symbol of the opening of the doorway of creation. So those of you who have imaginations can imagine all kinds of different things that this might represent. I'm going to go through a couple things here. It's the space between the two circles. It's a bold step out from unity. You could think of it as the fall, as the creation of physical matter, from unity to duality. And if you look down at the floor, you'll see black and white squares. The concept of duality, the concept of binary, opposites, is all over the place. And it's a profound and very simple concept. So, in polarity, we have the illusion of separation, right? As well as the possibility of reparation, repulsive and attractive forces working at the same time. Some of the words for separation: discord, difference, dispute, dissent, disunion, difficult, dilemma, divide, distinct, distance, distinguish, disgruntled, distribute, diverge, dichotomy, doubt, duo. They all start with the letter D. Disease, yeah. Deuce, duet, duel. And then words for joining: twin, twain, between, twine, twilight. Birth and creation can only exist within polarity. So the dyad is the basis of every creative process. Life is not limited to one pole or the other, it's in between. Polarity is the necessary condition for the existence of the physical universe. It's represented in a lot of different ways by this shape. So in this construction, it's providing the archetype of the door. If you put a square on the bottom, which we'll learn to do in a minute, I'm not doing the construction for that yet, but there's a construction for it, then what happens is, now imagine every great, beautiful stone cathedral you've ever walked into. Have you ever looked up at the door? They all kind of look like that. And all the windows, and Gothic arches do that. So that's not an accident. That's by design. It's the doorway. Oftentimes, Christ is placed in the vesica piscis, above the door. You'll see that in great churches and great cathedrals. And that's literally the divine emanation coming out from the womb of creation. Right above the door to a church. Now, it's not on that one, but it's a common thing.
So did you say something? I was trying to write it down because I thought it was brilliant. Life is not limited from one pole to the other, it's in between. Did you say something like that?
Yeah, so I said that the dyad is the basis of every creative process. It's that opening, that all the shapes that come out of it. Life is not limited to one pole or the other. It's in between. So polarity is a necessary condition for the existence. You have neutrons, you have protons, protons and electrons and neutrons, right? And that gets into trinity. But you have opposing forces. You have positive and negative, light and dark, male and female, up and down. You have these basic polarities that we live in. And a lot of our life is managing opposites, managing extremes. So we're kind of playing in the middle, and we're trying to navigate this thing. This is a representation of that. Now, these shapes come out of the vesica piscis, and they create familiar shapes. So that's kind of interesting to me. Three. Balance. This is the number 3. We're going to do 3 now. Physical structure. Smallest area, largest perimeter. It's kind of the opposite of the circle, which is the largest area, the smallest perimeter. The archetype for the triad is tripartite wholeness. That sounds fancy and complicated, but it's systems that are made of 3 things. So you could think of the tripartite wholeness, beginning, middle, end. I've got a whole list of them here. You've got Osiris, Iris, and Isis, and Horus in the Egyptian system. In the Hindu system, you've got Brahma, Vishnu, Shiva. In the Christian system, you have the Father, the Son, and the Holy Spirit. You've got the maiden, the mother, the crone. You've got our tripartite system of the American government that was created by you-know-who, legislative, executive, and judicial. These are really powerful 3-part systems. So 3 sets the stage for all the other numbers, just as the triangles dictate the study of trigonometry, the study of space. Euclid used triangles to describe geometry. Trigonometry is the study of triangles. Trigon is Greek for 3 sides. There's a long list of things that come in 3s. So the construction for a triangle, we're going to do the vesica piscis again. So now turn the page and do a vesica piscis. And, huh? What's that?
Did you say do another?
Yes. So remember, most of these constructions start with the vesica piscis. So you're going to do a whole bunch of these. So when you turn the page and you do the vesica piscis, you should have 2 circles of the same size, and the center of one circle is on the edge of the other circle. I'm just going to give you a minute, because I just threw a lot at you, but I think you can handle it. It's about to get even crazier.
That's reassuring.
Yeah. So, draw a vesica piscis, and I'm going to go ahead and give you the next thing. Once you've drawn that, you're going to connect the middle points. So I'm just going to go from table to table and just make sure everyone's good. Yeah, you're way ahead. I'm not worried about you.
I got lost. I took it off.
That's perfect. Yeah. No, that's good. Now you want to make sure that you don't change the width of your compass.
Yeah, okay.
Okay. Because if you change the width, then
gonna mess it up.
you'll lose it. And the other thing you can do is hold it on the top and then tilt it so that you're just kind of tracing it like that. It's almost like a slight tilt.
Okay.
There you go. One thing you might run into with that compass is if you push down too hard, you might start getting a thick line. And if it gets really thick, you might want to switch it out for another pencil or something because it'll start losing accuracy. That looks good. That looks good. There you go. You got it. So you may notice, let's think back about the rules of construction. I think everyone's looking pretty good. There's, if anyone's having any problems, just raise your hand. So focus back here for a minute. The rules of construction are that you can connect points that already exist, right? So we have 2 more points now. You got one up here, and you got one down there, right? So now this is going to start expanding. Connect them. Now you have a perfect triangle. So this is a very straightforward, simple way to draw a perfect triangle. So you'll use your straight edge, you'll take your ruler, and you'll put the ruler against the points, and you draw a line connecting them. Everybody got it? Raise your hand if you don't have it. Okay, cool. So I'm going to introduce a new concept now. This is the concept of expansion and contraction. So you can take a shape. So we've got the triangle. Here's another one. We can draw a circle on top. I saw some of you already did this. You can doodle as much as you want. Just remember that. If you draw the triangle inside of that, then there's another triangle inside of that. And if you start extending lines and drawing more circles, then you can start drawing fractals. And you can contract things inward, or you can expand things outward. So that's an expansion outward. Now, I'm not showing you the construction to get from there to there, because it's too many steps, and I'm trying to keep this intro level. But there's a lot that you can do with these shapes. And again, get these books and study it, and you can go into some pretty wild places. I'll demonstrate some intricate and complicated ones in a minute that you don't have to follow along with, that'll just give you cool ideas. But if we go back here and we go, okay, point within a circle, there's the 1, vesica piscis, there's the 2. Now, if I take my compass and put it right there on that point and draw a third circle, I've got 2 triangles right there. The use of a triangle. You could do it like this. It's one way to do it. Or you could make a triforce. And it can go inward and outward, and it can expand and it can contract. All of the shapes do this, but one of them, when it does it, it becomes 3-dimensional. We're not there yet, but it's pretty cool. Does anyone have any questions before we move on to 4? No? All right. So the tetrad. The tetrad is 4. 4 is symbolic of Mother Earth. 4 directions, elements, square roots. The archetypes of justice, groundedness, earth. We have a symbol here of the medicine wheel. The Egyptian and the Mayan glyph for earth is the same glyph, and it's broken into 4. The Egyptians and the Mayans lived across the world from each other. How did they have the same symbol for earth that's based on the number 4? That's pretty interesting. Anyone know? I don't know. Yeah, I couldn't tell you. I wasn't around back then. Yeah, something cool. Yeah? Okay. They all just stared into a dodecahedron and it got them there. So the word for earth, the word for matter is mater in Latin. Mater is the root for the word for mother. And the word for matter, it's all the same root. And the word for father comes from the root pater, which is pattern and matter. Matter and pattern. Put them together, mother and father, that's what everything is. It's physical things that follow patterns. So it's kind of interesting to look at matter plus pattern equals natural forms. Mother plus father gives birth to everything in existence. So all of these ideas are incorporated in the study of sacred geometry. Now we're gonna learn how to give birth to a square now out of the vesica piscis. This first method uses a right angle that naturally comes out of the vesica piscis. So what I want you to do is draw yet another vesica piscis. And with that vesica piscis, instead of drawing the triangle, hold on, let me turn this. Instead of drawing the triangle, connect the dots with lines that cross in the middle. So everybody got that?
How do you draw the horizontal line? You just kind of got to guess the middle of it?
You don't have to guess. Great question, though. I love that you asked. So if anyone has a question and you're struggling with something, don't keep your mouth shut. Like, ask me. So right here, we have 4 points already defined. So what I'm going to do, pretend like this is a ruler. I'm just going to put the ruler touching both of these points, and I'm just going to draw it.
Rest of the points are creation.
They're already there. Yeah, we'll go back again and you'll see it. So this is why the rules of construction exist. You're not just making up these points like out of nowhere. They come from already existing. Yeah, you're welcome. And maybe I should make them bigger. Next time I do this, I'll make them a little bigger so it's easier to see. But when you connect them all, you get this big plus sign, right? Now you can extend the lines as far as you want. Okay? And that creates the division of 4, which if you look at symbols, if you look at like crosses, they all follow that pattern basically. The equilateral crosses do. That's pretty interesting. So we're going to make this now. We're going to draw the Vescopices. We're going to draw the plus sign in the middle. And then we're going to draw another circle. So I'm going to slow down for a second. See where those lines cross? Put a point on that point and make the radius of your circle the other line, the other point. So what you'll do is the center of your compass is right there, and then the radius goes to there, and you draw a smaller circle on the inside. By doing that, what you've drawn is 2 more points. I hope you're seeing a pattern here. Everything connects to everything else to be valid, to be provable. Now, we can go through this some other time and bust out the Pythagorean equation and prove a bunch of stuff. And these books go into a lot of detail, and I've done a lot of that. But I'll just tell you, these points, all you got to do is connect them, and you got a square. You could think of it as a diamond or a square. So that's the construction for the square. So let's think about applications for this. What could be an application for something like this? You could be creating a piece of artwork that has to have divine proportion in it because it symbolizes something specific. You could be designing a piece of jewelry. You could be designing the floor plan for your living room, and you're going to redo it, and you want it to have certain elements in certain locations. You could be designing any number of different things. That's the beautiful thing about design. It doesn't say what it is that you're designing, but the principles hold true. So that's the square, the symbol of Earth. Now, if we zoom in a little bit, you can really see. Just stare at that for a minute. It kind of looks like an eye turned sideways. What else? Does anyone see anything peculiar there? Do you feel like you're looking down at something familiar? Yeah. It's a pyramid. So 2-dimensional shapes can be projected into 3-dimensional forms. So that actually looks a lot like an octahedron. So I'm just going to walk around with the octahedron for a second. You can pass me that. So if you look at the octahedron straight down, can everyone see? It's the same thing. So this is just going to keep repeating. These basic patterns will get more interesting as we go along. Now I'm going to give you another construction. I saw, Alex, you already had this. It's pretty cool. This one, if you want, you can do it along, but I'm going to move a little faster because I just want you to see it. Well, let's do this. I'll take a poll. Raise your hand. Do you want to go step by step and draw this? Or do you want to just see it? Okay. So.
I want to give it to you without having to work for it.
Yeah. Okay, just open your mouth and I'll just pour it in. All right. Make a Vesica Piscis. Yet another Vesica Piscis. Only this time, do you see how the line extends to the edges of the circles on the right and left on the extreme edges. I have now a vesica piscis, and I have a total of 4 points in a straight line that I can work with to define other things. That's going to be useful in a second.
My compass is like running out of discipline.
So I'll advise anyone with one of the little metal compasses with a pencil in it, turn your hand, take a look. So pretend like this is your compass. All right. The point in the middle is where the pressure goes. And if you can push it in just a little bit without damaging the table, to just kind of go through the paper slightly, anchor it, then if you look at straight on, the way to draw a circle, it's not like this going that way. You actually lean into it and drag the pencil behind you in a circle. And what'll happen is it'll just glide along the paper really gentle, and it just kind of barely touches it, and it just sort of graces the page. You don't have to turn the paper around. If you rotate the paper, I'm not gonna, I'm not naming any names. Ivan, no, sorry. You weren't the only one. But if you turn the paper, it's more likely that you'll make mistakes. So I recommend just tilting and just dragging. We're Now look at this bigger circle. Check this out. So what we're going to do is we're going to ignore this middle piece. This is a golden mean caliper. We're going to put the point right there and go all the way to the middle of the other circle and draw a really big circle. And what half of you probably did is half of you probably made a really big vesica piscis, and now you're falling off the page. So that's why you've got more paper. I'll give you a minute.
Are we going to need the whole circle?
Yeah.
Are we going to need the whole circle?
You're going to need, well, so watch. Yeah, watch this. Everybody look up for just a sec. I'm going to show you the whole thing, and then I'll rewind, and we'll go through it step by step. So we're going to draw 4 circles. So they're all going to have the same diameter. 1, 2, 3, 4. Okay? It's the same thing over and over again. It just goes from left to right. Like what? It does, yeah. Yeah, it does. Pretty cool. So what's going to happen, I'm just going to show you the rest of it, and then we'll rewind. So once we've drawn all these circles, you'll see that there's additional points up here that we're going to use. Now, if you're like Glenn or Alex, you're like going way ahead and having fun and just connecting lots of lines, and you could there's a whole bunch of crossings. There's all these crossings. Any one of them you can grab and then extend into something else and just go crazy. But if you want to follow this construction, grab these 2 points. So now we have 2 vertical lines. Then that creates these points. And when we connect them, we have a square. Not only do we have a square, we have something that's starting to look like a stained glass window in a church or cathedral, or a design in a temple. And that's because that's how these things are designed. It's really not that complicated. There's some basic forms, that's it. So I'm going to go back. Again, we got our vesica piscis. And you get 1 really big circle. Now, if you do this one correctly, then the other 3, it's just doing the same thing over and over again. You just kind of shift over, shift over, shift over. Does that make sense? But don't be discouraged if you can't do every construction as fast as we're going, because part of what you're learning is the symbolism. You're getting the experience of doing it. And one of the rules or one of the principles that I've told you is that physical things are not perfect. That means you and me, we are not perfect. And, you know, having been through math and geometry class and grade school and high school, you know, some of us have baggage around being yelled at in math class or whatever. That's not happening here. So don't yell at yourself in your head. Just do what you can, and we'll keep moving. So you do the next one, and the next one.
Does the order matter?
No.
Would that be considered concentric rings?
They're not concentric, but the center of every circle is one of the points on that line. That's the center of a circle, the big one. That's the center of and they're all the same size. So, but they're not concentric because they don't all have the same center. Does anybody have it? There it is. There it is.
Turn the paper.
Okay. Cool. Beautiful. Yeah. So now let's get the vertical lines in there. So think about where you're getting your points from. Everything comes from something, from somewhere. If you see a person that looks like they're doing really well, they probably had a teacher or a mentor or a strong father or a mother or somebody who helped them. Nobody does it alone. By analogy, none of your points, none of your circles, none of your arcs come from nowhere. They all come from a previously existing point or crossing. So, analogies are a good way to memorize information, you know? If you can connect it to something completely different, but it works, you're more likely to remember it.
These principles that the operative mason used.
Yes. The architects. And then the operatives would go build the stuff that the architects designed. So you could think of this as kind of an architect's workshop. Old way of thinking, old school thinking. Yeah.
I have a question.
Yes.
So, you know, the rule that we're working with, you know, everything has to come from something that already exists, right?
Right.
But that first point came from,
Nothing.
that's like one of the primordial
Yes.
theological principles, something out of nothing.
Yeah. So Warren had a really good point. I want to repeat and make sure it gets on the recording as well. He said, hey, this is interesting, Ernest, you're saying everything has to come from something that already exists. And yet that first point came from nothing. That's interesting. So I could give you my thoughts on it, but I've kind of already told you. Does anyone have any thoughts about that? Any ideas? Does that stir up anything? So it seems like a contradiction to say everything has to come from something that already existed. And yet that first point comes from nothing. What is that saying?
It's like, where did God come from? It's free. Where did the first point come from?
Yeah,
The first point can be anywhere, too.
it can be anywhere.
Anywhere and it's nowhere. It's particularly three dimensionals.
So remember, we started with a blank piece of paper. And I'm working you through the numbers 1 through 5. But we started with 0 for a reason. And the reason is that everything starts in the void. Starts with nothing. And the void expands and contracts and explodes and Big Bang, creation, whatever you want to call it. There's this moment of creation. So you are copying the moment of creation when you draw that first point in the circle. It starts with a point within a circle. Go ahead.
What if there was no void? What if that's, like, what if nothing actually isn't nothing, right? It's something. Because we're actually starting with a piece of paper, like, that's not no.
Right.
That's the thing.
Yes.
What if the idea of nothing
Yes.
is actually not a thing?
I love that. I will refer to the three worlds. The piece of paper is a type. It's a type of object. The symbol of a piece of paper is the potential, anything that could be. Your imagination gets to determine what it is. And then the archetype of that is the archetype of the void, of nothing. Space, emptiness. So I would argue that we just have to know what level we're talking on. If we're talking on the level of object, yeah, it's a piece of paper. I have a hand. My hand already existed. And then you could also, by extension, argue that the hand of God is transcendent of creation, and that that's what is creating. So God would then exist before creation existed as the prime mover, which is what St. Thomas Aquinas famously offered as his proof of God, that there's a first mover. So whether you believe that or not, we're imitating that every time we turn the compass. Yeah.
I also think it's interesting how when you start to like add lines to this, a mistake that was barely perceptible in the beginning,
Yes.
easily overlooked, becomes very obvious the more you
Oh, yeah. Yeah.
Keep playing that mistake on God.
Well, I want to be respectful of time, so I don't know if you can tell me how much we have.
5 minutes is 8, but I suppose it's really up to the crowd.
Okay, well, I will defer to Master, Lodge, and the crowd. But we can always do a part 2 or whatever, but nothing you do is going to be perfect. Just remember that. So little imperfections can land in very great imperfections later on. There's a butterfly effect. So I think what I'd like to do to kind of wrap this up is go through some visuals that I created to just show you where this can go. So I'm actually going to skip 5. I'm going to show you a little bit of golden mean Fibonacci. If it's okay, we'll go over by 5 or 10 minutes, and then we'll call it close to on time. And then there's plenty of follow-up that can happen, because this is scratching the surface of a rabbit hole the size of Jupiter. So I'm going to jump through. There's another construction for 4. You don't need to do this. You can just kind of watch, enjoy the slideshow for a minute. You zoom in, and you can collapse it inward and create a grid. Every number can create a grid. So the grid is a matrix where you can pick your points, fill stuff in, and all of a sudden you have beautiful tiling. Islamic tiling does this at a very high level. You may have seen things that look like that. I mean, that's kind of a basic form, but it goes on and on and on. The same thing, if you keep building out, you get growth. And the growth is following different sequences. This is a square root of 2, or a binary sequence. And it's growing in a way that's very linear. And then what happens at the very end, if you see that little thing that looks like the Gmail logo, right there, looks like a Gmail.
Looks like an apron.
Yeah, or an apron. Then it also looks like a triangle on top of a square. It's all inside of that shape. So the pentad, that's 5. There's some constructions here that I'm not going to run you through. If anyone wants these later, just contact me and I'll give them to you. But if you go through, and you'll see, this is way too ambitious, but basically, we've got the ability to go from the Vesica Piscis to a 5-pointed symmetry pretty quickly if you know how to do it. And then that can be extended in lots of directions. I'll do another construction. That goes to the 5-pointed symmetry again. And now if you start extending the lines inward and outward, what you get is tiling. So look at the tiling and think about this for a second. All these shapes, if you got scissors and cut this out of a piece of paper, you're looking at the construction models for three-dimensional shapes. And I've actually built a bunch of them. Pass them around in a minute. That's no small thing. And it can go infinitely deep, down or up, in or out. So this just goes on and on and on. Now I'm going to talk about the Fibonacci sequence for a second because, Warren, you mentioned imperfection, okay? The Fibonacci sequence is it's a number sequence that's used to model population growth, plant growth, branching patterns in trees. In this case, it's rabbits. You see there, new rabbit born, rabbit matures, rabbit survives. X number of rabbits die every cycle, and then you're left with this basic pattern that goes like this: 1, 2, 3, 5, 8, 13. The numbers go up, and they go up in a particular sequence. And if you divide the numbers by the previous number, the first one you get, 1 divided by 1 is 1, and then 2 divided by 1 is 2. That's the second one. The third step in the sequence, 3 divided by 2 is 1.5. Then you get 3 plus 2, that's 5. 5 divided by 3 is a little bit, like, I don't know the exact number, but it's kind of, you see this big red line here? This big red line is representing the golden mean. And when you take the Fibonacci sequence and you divide one term into the term before it, you go above it. Then you go below it. Then you go above it. Then you go below it. And as you go further and further out, it makes a little collapsing wave. And it never touches the golden mean. Everyone's body is based on Fibonacci ratios. All the different parts of our bodies are based on the golden mean and the Fibonacci ratio. But none of us are perfect specimens of these ratios because it's an irrational number that goes on for infinity that you can never hit. Except for you. And that's why when you turn the paper, it's beautiful. So I'll pass these around, but you can measure your hand, your arm, your head, but you'll never actually hit the golden mean. And I think there's something beautiful about that, because the golden mean is this divine perfect ratio that's found in art, architecture, DNA, the 5 atomic solids, but it doesn't actually exist in the world. It doesn't exist. So perfection doesn't exist. So the art of perfection, the pursuit of perfection, is ultimately, you're never going to get there, but you're always going to get better and better and better and better. So there's something beautiful about that. I'm going to skip ahead a little bit. There's a construction for the golden mean. There's a construction for the Fibonacci spiral. There's this construction for the golden spiral. I want you to see this. And this is the last thing I'm going to leave you with. And this is something you can take home and play with. So books. So after we're done, anyone who wants to talk, I'll stay a little longer if you have any questions. I'm going to show you the flower of life and Metatron's cube, but I'm going to show you something about it. Raise your hand if you've ever heard of Metatron's cube. So some of you have. You'll know by the end of this. But I'm going to show you something about it that you might not have ever seen. Yeah, exactly. So, with the flower of life, you start with the Vesica Piscis. And it's really simple. You just keep going around the circle. You've probably all done this board in a geometry class in the 6th grade. Some of you may have known what it was, and some of you may not have. If you go all the way around the circle, see how I just keep moving? And then it connects back with itself. Has anyone ever seen this before? It's pretty familiar. If you connect the dots, first of all, that looks like the back of the $1 bill. That's kind of cool. There's this thing with the little dots. Is it the back of the $1 bill or is it the back of the Great Seal? What is it that looks like? There's something with all the stars. Well, there's a lot of things that this looks like. So, I'll leave it to you to connect the dots. There's a star. I might be thinking of a different symbol that's on. Maybe it's not the $1 bill. Yeah, sheriff's badge. You start connecting the dots, and okay, you've got the 6-pointed star, the Magen star, the Star of David. You put the circles back in.
That's the seal of the United States, right?
Yeah, it's on a lot of stuff. Okay. Well, let's keep going though. So now, if I make it smaller and then I blow it out, now I've got more circles. All I did was take things I already had and expand it. And I'm going to do it again. Flower of life. Do you remember the 5-pointed thing where it made a matrix? Remember that, like where it made like this, like a checkerboard. So if you look on the floor, that's the flower of life of the number 4, right there. The 5-pointed is the flower of life of the number 5. The Triforce in the Legend of Zelda is the flower of life of the number 3. This is the flower of you can do this with all the numbers. Well, check this one out though. This one, you can fill in all the circles that touch each other's edges. And now you have a diagram called Metatron's cube. And Metatron's cube, when you connect the points in the middle of all these circles, it gives you an isometric view, 3-dimensional isometric view down from 2-dimensional forms into 3-dimensional forms. And there's a huge, huge mistake in the way this is taught. If you've ever read The Flower of Life by Drunvalo Melchizedek, you may be familiar with this. There's a huge mistake in here that I find really amusing and also really helpful. So I'll get to it now. Watch. If you connect all the centers of all the circles that touch each other, you get this crazy looking thing. And it looks like you're staring into like a hypercube or something. Like it's kind of visually confusing to look at. And as you look into it, if you know which lines to erase, then you'll get a cube. That's a 3-dimensional. So who's got the cube? Can you guys hold that up? So if you look at that cube straight on the point, if you were to take a picture of it and imagine kind of flattening it like a shadow to 2D, it will align with this perfectly. All the angles are correct. Okay, thank you. Got the cube. And there's a bunch of them, right? Now I did a dark version of it so it's easier to see, because it's kind of hard to see on light. So there's your cube. All right, so far so good. We got 4 more to do. I hope they all work. Tetrahedron. Who's got the tetrahedron? So again, these are, if you could pick that up and imagine you're looking straight down on that. All right, that one works. That's cool. So remember what I said, these are meditation tools, teaching tools. You are viewing this and seeing it in your mind and meditating on it to imagine 3-dimensional space. Can you imagine someone 5,000 years ago learning all of this and no one ever told them that DNA follows the same shapes? That's kind of cool. Okay, now the octahedron. That one's pretty straightforward. If you could pick up the octahedron, just look at the octahedron. If I'm looking straight down on it, looks pretty good. It's in perspective. Now, you could argue that if I get really close to it, it'll warp the perspective, or if I'm really far away, it'll warp the perspective. But if you flatten it, that's in perspective. Now the icosahedron. Yes?
Am I correct in assuming that there's something about the proportionality of all this that you can figure out what distance it is, especially looking at these for the correct proportion?
That's a good question. I don't know the answer. So that's something to investigate. The exact location in Z-space you need to be in to see it correctly. So good question. The icosahedron,
What's that called?
icosa, which means 20.
Icosa?
Icosa. So that one is wrong. That one's wrong. And the reason it's wrong is because you can't get an accurate visual on the icosahedron on tracing it on paper without using the golden mean. You have to use a golden mean. This isn't using the golden mean. This is using 6-fold symmetry, 30-degree angles, hexagons, points that are defined by those points. And I'll show you the correct view, and you'll be able to recognize it visually pretty quickly. But I'm going to do the dodecahedron next. So that one, if you could hold that up. Same thing, the dodecahedron. And again, this one's also slightly off. And if you put it in front of you and just you hold it up, if it was a dodecahedron, and you kind of compare it, like you can try it, it's not quite right. And this was really bothering me when I was learning this originally, in 2002, when I got really into this. So I started doing perspective studies on spheres. And I got a bunch of spheres and super glued them together in different configurations, and like would shine a light through it and have it hit the paper and trace it. And I realized in order to get this right, you have to do a construction. Robert Lawler has this in his book too. It's kind of buried. And you see those points right there? See all these points? They have to push out just a little bit. And they push out with a construction. That little cut right there cuts this line in a golden mean ratio. It's 1 divided by golden mean on one side, and it's 1 divided by golden mean squared on the other side. And when you cut it there, it pushes all the points out. And when you do that, you get an accurate, see the difference? It pushes it out. Now you could argue like this is really nerdy and why do we care? But you're here. So I rest my case. But check this out. It looks more beautiful. It looks more like what I'm looking at. And I think there's something important about an accurate reflection. If I'm considering myself as playing the role of in the image of the Creator, sort of creating these forms and just playing with creation, I want it to be accurate. I think that's important. Same thing with the dodecahedron.
That's like when they make, like the parking lot, they make it inaccurate, so it looks like.
Yeah. That's a whole other game. But you see that, so the slightly inaccurate one's easier to draw. The accurate one is harder to draw. So in order to learn how to do this, you have to learn some technical stuff that's kind of hard. And the process of doing that sharpens your intellect. So the real study of sacred geometry is about sharpening the self and the intellect. And it's the same thing you would get from studying music, philosophy, from studying the trivium and the quadrivium, the 7 liberal arts and sciences. It's really about what it does to you. So in the interest of time, I'm not going to go on any further. I will give these constructions to anyone who asks for them if you want to do the other ones. And I'll be here hanging out, answering questions and chatting as long as you guys are around.